This is part one of a multi-part series where we will dive deeper into Amazon Bedrock. Amazon Bedrock is a generative AI service from AWS. This is going to be multiple videos. In each of those videos, we will get into different functionalities of Amazon Bedrock, and we will also look at some code snippets as we go along this series. But for today, what we're going to focus on are three topics. Number one, what are AWS generative AI services? AWS has a bunch of generative AI services. We want to make sure that we clearly understand which services focuses on which activities. And for what use cases should you pick these services? Number two, what does it take for you to build a Gen AI application? Whenever we talk about Gen AI application, the thing that always comes to our mind is large language models or foundation models. But there is more to it than just the models. We'll look at all the capabilities that are required for you to build a Gen AI application. And finally, we'll look at Amazon Bedrock and its capabilities and how it helps you building the Gen AI application. Okay, so now let's get into the details of AWS's generative AI ecosystem. There are three different personas that uses generative AI in any enterprise. Again, I'm looking at it at a very high level. The first persona is a Gen AI consumer. Think of Gen AI consumers are personas who are wanting to use Gen AI applications to improve productivity. The productivity could be business productivity or developer productivity. There are two services that are geared towards improving productivity. Amazon Q Business is for business productivity, and Amazon Q Developer is for developer productivity. The next persona that we're going to look at is Gen AI builders. This persona is focused on building an end-to-end generative AI application. Again, as I mentioned in my earlier slide, when you think about building a Gen AI application, models are just one piece to the puzzle. Then you're looking at vector databases, agents, evaluations, guardrails, orchestration, and much more. We'll look at all of those things in detail in the next slide. But whenever you think about building an end-to-end generative AI application, think Amazon Bedrock. The final persona is model tuners builders. So this persona, think of data scientists and ML engineers who are wanting to build their own large language model, pre-train their large language model, fine-tune them, or even take it and deploy it for cost and performance. So here is where Amazon SageMaker comes into play. SageMaker has been in existence for the last 5 years. However, what AWS has done is taken Amazon SageMaker and extended SageMaker capabilities to take care of large language model requirements. So if you're thinking about building an end-to-end pipeline of collating the data for large language model training, pre-training, fine-tuning, deploying the model, and monitoring the model post-deployment, SageMaker is the tool that you should be thinking about. With SageMaker, you can pick your infrastructure of choice. You can either use GPUs or use AWS's own silicon, which is Inferentia and Trainium. For the purpose of our discussion, we will stick to Amazon Bedrock. If you're really interested in Q for Business or Q Developer, I will be posting additional video series going into much more details on each of those services. Okay, so before we jump into understanding Bedrock capabilities, let's look at what is required for you to build a Gen AI application. At the heart of it, obviously, is a foundation model. So you take a prompt and send it to the foundation model. The foundation model generates a completion out of it. So this is like a very bare minimum Gen AI application that if you want to build. But these applications are not fit for purpose for any enterprise grade. So the next thing that you need is evaluations. Why is evaluations important? Because there are so many number of foundation models today, and not one model is fit for purpose for everything. So there is no one model to rule them all. So depending upon the use case, you need to pick the right foundation model, not only from the functional aspects of it, but also from a non-functional aspects from cost, latency, and performance. So model evaluations are a key feature for you to build your GenAI application to pick and choose the right foundation model for your use case. Once you have figured out what are the types of model, what are the foundation models that you want to use for your GenAI application, then comes prompt management. Every model, every foundation model, you have to have a specified way you prompt these models. Llama expects it, Llama 3 expects it in a particular format, Claude expects in a different format, and so on and so forth, right? So it is important for you to understand and manage prompts and the versions and keep it for your use case. The next thing is guardrails. The prompts that you send to the foundation models have to be uh, secure. So when I mean secure, it is free of bias, violence, hate related information, or even talking to a specific topic, right? Similarly, any information that is getting generated from the foundation model or the completions from the foundation model have to be hallucination free, bias free, and in line with the expectations of the consumer. Without this, when you put any of these foundation models into production, it might provide irrelevant results, thereby reducing the confidence of your overall GenAI application. So having the right set of guardrails and configuring these guardrails the right way for your application and your use case is extremely important for your GenAI applications. When you're talking to a foundation model using a prompt and a completion, it becomes a singular conversation. However, you wanted to have a multi-turn conversations, meaning you wanted to have the conversation history of all the conversations that you're having, and you're sticking to the context. So you need some sort of a conversation memory to be stored as you have these conversations with the foundation model. So the next time you talk to the foundation model, you take the conversation history and send it to the foundation model so that the model understands the context in which the question is being asked. The next capability is fine tuning. Most often than not, the foundation out of the box foundation models might not be fit for purpose because it lacks the enterprise knowledge that is required. So you're working on a particular enterprise and you have to feed your enterprise information into the foundation model. Given these foundation models are trained on internet data, it lacks any of your enterprise data and information. A couple of ways that you can actually fit your enterprise data into foundation model. The first pattern is fine tuning. Essentially, you take your model, you take the foundation model and fine tune it on your enterprise data. The other option is using a RAG based approach, which is retrieval augmented generation. Here, you are standing up a knowledge base, usually a vector database, where you take your enterprise data and vectorize it and store it in the knowledge base. And when you ask a question to the model, the question first gets redirected to the knowledge base where the retrieval of information happens. That retrieved information is then augmented onto the prompt and sent to the foundation model. The foundation model takes the augmented data and then generates the final response. Hence, retrieve, augment, and generate. Right? So that is another way to take your enterprise data and feed it into the foundation model. One of the biggest problems with foundation models is hallucinations. A lot of enterprises that we work with deal with very sensitive, regulated information. So any unreliable information sent to the consumer reduces the overall confidence and reliability of your GenAI application. So it is important through which you can actually moderate the responses sent to your consumer. So this is where moderation and grounding of the responses happen. We will get into much more details of moderation and grounding at some point of time. But bear in mind, there is a lot of art and science behind this, and we'll talk about it in much more detail. Of course, we are using the foundation model and creating responses out of it. But more often than not, you might actually want your GenAI application to take some actions on your behalf. So here is where agents, tools, and functions comes into play. So as you are conversing with your GenAI application, you want your GenAI application to figure out the intent of your question and act accordingly. It could be that you are wanting a response from the foundation model uh, or taking an action through a tool or a function. So your GenAI application needs to provide those capabilities as well. Let's say now you've implemented all of these capabilities into a GenAI application. Now you have to take this application and put it into production. This is where the ops comes into play. Now there are multiple sets of ops that are required for you to take this GenAI application into production and maintain it in production, starting with data operations. Say, for example, if you're standing up your vector database or a knowledge base, how do you set up your data operations? Whenever new data comes into the enterprise data, how do you set up a pipeline through which you can actually continuously create your vector embeddings and keep it up to date? So that is one kind of a data ops that you need to be worried about. LLM ops. Here is where every time there is a new foundation model coming in, or if you want to even fine tune your foundation model, then what kind of ops capability or pipeline capability that you need to set up to keep your foundation model up to date. That's where LLM ops comes into play. Then prompt ops. As we mentioned earlier, prompts differ based on the model, and there is a requirement for you to manage prompts based on the models and also the versioning of the prompts so that you can go back and forth on the prompt management and making sure that the prompt management is up to date for your operations. Then DevOps. For example, if you're standing a user experience on top of your application, now you're thinking about how do we take this entire application, convert it into some sort of a CDK or a Terraform and deploy it and use DevOps to manage it in for production. Finally, you're also looking at making sure that enough level of observability is set up within your GenAI application. This could be observability on performance, latency, cost, error handling, and so on and so forth. A good amount of telemetry monitoring and cost tracking is also required. Now, when you start thinking about building a GenAI application, now you can see that the foundation model is just one piece of the puzzle. There are so many other components that needs to be set in place, orchestrated well enough to and working in tandem and having a plan for you to take your application from proof of concept into production. So this is a long drawn process. So it is important for a service to have all these capabilities under a single umbrella. In addition to that, you're also always worried about security and responsibility. The other one is cost performance we talked about, and choice is a very important aspect. This space is exploding at such a pace that there are 130,000 models in large language models in Hugging Face, 10,000 variations of Llama 3 model in just 3 days, and so on and so forth, right? So choice is a very key aspect. You need choice on foundation models, you need choice on knowledge bases, agents, evaluations, conversation memory. Pick anything, you need choice and options. So this helps you to keep in line with the pace of the industry, at least to a reasonable extent. Given that now you understand all the capabilities that are required for you to build a GenAI application, let's go to Bedrock. Now, Amazon Bedrock is a service that is focused on providing all the capabilities that are required in the, as you saw in the previous slide, under a single umbrella. For example, Bedrock has Model Hub, where there are multiple types of models that are available. As of today, there are 31 models that are available within Bedrock, and these models range from Amazon's own first-party models to partner proprietary models to open source models or open weights models. In addition, through Bedrock, you can actually customize your own model, or you can bring your customized model and host it on Bedrock. Knowledge bases is another capability. Again, in knowledge bases, we provide a lot of options. Today, we support 5 different knowledge bases: OpenSearch, Redis, Pinecone, MongoDB, and Aurora. Guardrails are extremely configurable in nature, and it has PII detection to bias detections, hallucinations, prompt injections, and topic modeling, and so on and so forth. Evaluations, again, we talked about the importance of evaluation with the number of models that you have. With Bedrock's model evaluation, we give you automatic model evaluation and human in the loop evaluation. You can choose to use the evaluations that are provided by Bedrock directly, or you can bring your own evaluation metrics and data. Agents, today there is a built-in agents from Amazon Bedrock. However, if you choose to use LangChain or a Llama Index or any of other open source frameworks, those are also supported within Amazon Bedrock. The multiple ways that you can access these capabilities. Number one is SDKs and APIs. Number two, Amazon Bedrock provides you with a built-in user experience, which is called as Bedrock Studio. Three, there are multiple other services where Bedrock is embedded in. For example, SageMaker Canvas is one where you can actually log into SageMaker Canvas and access the Bedrock models and its capabilities. Similarly, Amazon QuickSight, Q, Chatbot, all of these things are using Amazon Bedrock behind the scenes. There are 3 important things that you need to be aware of with Bedrock, in addition to what you know about their capabilities. Number one, security. Security is day 0, meaning the models that are hosted within Bedrock or within your AWS environment, and any data that you send to these models does not leave the AWS environment, and none of the team has access to the data that is sent. Only the customer has access to the data that is sent. That data is not stored, not used for any kind of retraining purposes. Number 2, the entire capabilities of Amazon Bedrock is managed and serverless. What does it mean? It means that you do not have to provision these services. You do not have to scale these services. You only pay for what you use. And this goes to every capability of Amazon Bedrock. Every capability, from models to knowledge bases to guardrails, everything is serverless in nature. Number 3, choice. Choice is something that you're going to see across all these capabilities. The fourth one, which is also very important, is modularity. Meaning, with Amazon Bedrock, there is no reason for you to use all the capabilities of Amazon Bedrock. You can pick and choose the capabilities of Bedrock to use. It is extremely modular in nature. So for example, you can use your own knowledge base if you've set up something with Elasticsearch, let's say, or Solar, and use the models, guardrails, and agents from Amazon Bedrock. Similarly, you built your own model, you hosted your model on SageMaker. You can use those models, but use the knowledge bases from Bedrock and guardrails from Bedrock and so on and so forth. It's extremely modular in nature. Each of the capabilities are independent and modular in that sense. Now that you've got a good understanding of all the capabilities of Amazon Bedrock, in part 2 of this series, we will have a hands-on demo of Amazon Bedrock, and we'll get into the details of experiencing it from the AWS console. Part 3, we will focus on coding it using Amazon Bedrock SDKs. Thank you.